In this section, we will discuss two measures of central tendency, the mean and the median. Throughout this course, we will use the symbol lowercase n to denote the sample size, and the symbol capital N to denote the population size. Two symbols that we will also use are mu, which denotes the population mean, and x bar, which denotes the sample mean. Computing both of these measures are very similar. In both cases, you must sum up all of the elements that you have and divide by the total number of elements. Let's start by exploring this example where we have 5 football player weights. Often, when we see this summation symbol, it will not have indices on the bottom or the top. When those indices are present, it tells you exactly which elements to sum. If these indices are not present, it means sum all of your elements. For this example, we have to sum all of our elements in our sample above and then divide by 5, which is the total number of elements that we have. By summing the elements, we get a total of 1387, and then dividing by 5, we end up with a mean weight of 277.4 pounds. In this example, we have the monthly rents for 70 one-bedroom apartments in a city. In order to compute the mean monthly rent for these one-bedroom apartments, we must sum up all of the elements listed in this table and then divide by 70. Summing these elements, we get 34,356. Then we divide by 70, which is the number of elements listed in this table, and ultimately we obtain a mean value of $490.80. The median. The median is a measure that is often incorrectly used interchangeably when discussing the mean. The median is a value such that at least 50% of all measurements are less than or equal to its value, and 50% of all measurements are greater than or equal to its value. The median is a measure which is often used to discuss annual income and property value data. Unlike the mean, the median is not sensitive to extremely large or small values, which could skew a mean value. Here we have the basic steps for computing a median. First, you should arrange your values in ascending order, that's smallest to largest. Second, if the number of measurements that you have is an odd number, the median is the middle value. Third, if the number of measurements that you have is an even value, then the median is the average of the two middle values. In this example, we have the salaries of 13 doctors. We have arranged these salaries in ascending order. Since there are 13 numbers present in this data set, this is an odd number, so we can identify the number that is exactly in the middle. After arranging these numbers in ascending order, we see that 152 is the number in the middle position. There are 6 numbers that are smaller than or equal to 152, and also 6 numbers that are larger than or equal to 152. Therefore, 152 is our median. It is the number in which at least 50% of our data values are that value or smaller, and 50% of our data values are that value or larger. Now let's compute the median for these numbers. In step 1, we arrange our numbers in ascending order. We also note that we have 8 data values. In step 2, since there is an even number of data values, our n value is 8, we must identify the 2 middle numbers. In this example, 43 and 45 are the 2 numbers in the middle. We have 3 numbers that are either that number or smaller, and we also have 3 numbers that are either those values or larger. Therefore, since 43 and 45 are our middle numbers, we know that our median is the average of the 2 middle numbers. This average is 44. Therefore, our median value is 44. Hands-on practice. You should pause the video at this time and practice computing the mean of these numbers. When computing the mean, you should have followed these steps. First, placed your numbers in ascending order and noted that there are 9 data values. And second, since there's an odd number of data values, you should have identified your middle number, which was 62. And for this problem, 62 is our median. Let's have a brief discussion regarding the mean and the median. For example 4, when we computed our mean and median, we found that our median was 44, and had we computed the mean, we would have obtained 66.625. For example 5, in computing the median, we obtained 62, and had we computed the mean, we would have obtained 63. If we were given these 2 data sets and asked to describe the central tendencies of these data sets, the median would have been much more appropriate for describing these data values. For the first example, the median was 44. And the overwhelming majority of our numbers are grouped around the number 44. The mean for this data set, however, was 66.625. This number was skewed by the presence of one large number in this data set, which was 225. For example 5, since we didn't have any exceptionally large or small numbers for our data set, the mean and the median were relatively close values. In short, whenever you have a data set which has an unusually large or small number present, the median would be much more representative of your data set.